Okay, we want to take activity 7. And it says that we have a model that's given by the equation, and it describes the growth of a population that's limited by various factors such as overcrowding and lack of resources. So we have the expression there. It tells us that where nt is the number of individuals in the population, n naught is the initial population size, n infinity is the maximum population size possible due to various limiting factors, and r is the rate constant. Make a surface plot nt versus t and n infinity, assuming 0.1 per second, and n naught is equal to 10. Let t vary between 0 and 100, and n infinity between 100 and 1000. Now it tells us that we should label the axis and provide a suitable title for the graph. Now, when we want to make a surface plot, you need to understand that we can't just use normal vectors or scalars for our plots. MATLAB will give us an error. So what we need to do is that we have to get what we call a mesh or a mesh grid for it, right? So we'll look at that very soon and we'll try both cases and see what MATLAB will give us. But now let's list out the things we have. Okay, they gave us the n naught, which was 10. N naught, which is equal to 10. And the question also gave us r. So it might not have explicitly written r over there, but if you look at it, the unit here is per second. It said assuming 0.1 per second. And if you check here, t is going to be in second. So r has to be in per second, so that whatever is in the exponential will not have a unit to be dimensionless. So per second will cancel out second, and then we can have our exponential term. Everything the exponential shouldn't, when you sum all the terms the exponential, the final unit shouldn't actually be a unit, it should be dimensionless. So you know that r is supposed to be 0.1, so r is equal to 0.1 per second. Now let's look at the other things that we have. It said make a surface plot of n of t versus t and n infinity. And they said that let t vary between 0 and 100, and n infinity between 100 and 1000. So I can see that my t is equal to from 0 to 100, and then my n infinity is equal to from 100 to 1000. Right. Now let's write out the expressions. I can see that n is equal to n infinity over 1 plus n infinity over n naught, all of that minus 1. So let me bring another bracket around it. All of that minus 1, and all of this times exponential minus r times t. So let me put my final bracket as the denominator, and then let me put all my dots in there so that I know that I wouldn't have any issue anywhere. So this is going to be my expression. Now let's say we wanted to do a surface plot, and I just typed surf maybe n infinity comma t comma, no sorry, my function is n, so surf n. This is how we do surface plots. We use the surf function, so n infinity comma t. If I should try running this, realize that it's going to give me an error. Let me see. Okay, so it said that they have incompatible sizes. Okay. So the reason why they are having incompatible sizes is because, so this is another thing that I was going to address, but I'll just address it later. Let me just do it now. The reason why they have incompatible sizes is because if you look at t from 0 to 100, MATLAB is going to increase it by a value of 1 till it gets to 100. So t will have a certain number of terms. If you look at n infinity, it's from 100 to 1000. It's also going to increase it by 1, so n infinity will have a number of terms. So if we check the workspace, realize that n infinity has about 901 terms and t has about 101 terms, so it wouldn't work well in this case. If we want the number of terms to be equal, then we need to rather work with the linspace function. So I can say that t is equal to linspace, my first value which was 0, my last value which was 100, and the number of points I want, so let's say 20. And then for n infinity as well, I'll say is equal to linspace, my first value which is 100, my last value which is 1000, and the number of values I want, which is 20. Now they all have 20 elements each. So now let me clear here so that we can run it again. Good. So this was the error I wanted us to see if we use just the self. So it says that Z must be a matrix, not a scalar or a vector. So for us to use the self function, we are not going to have to work with scalars or vectors. It has to be a matrix. And how do we do that? We use the mesh grid function. So let me go down and then come up here. So what we are going to do is that we would say that we can say maybe x comma y. You can use any values you want to use, right? But just know that the first value you use here, let me type it out first, is equal to mesh grid t comma n infinity. So we are going to get a mesh grid of t and n infinity. So the first value here, the x is going to be assigned to the t's and the y is going to be assigned to the n infinities, right? So let me run that. Let me put a percentage so that it doesn't run this. It just takes it as a comment. And then let me run this. Let me run it again. So we see that it's going to form a matrix now, considering both t and n infinity, right? So now if we decide to put it into our expression, we can now do this, and if we run it, oh, a minute. Yes, so the reason why we are still getting the error, so remember xy is now what we put in the mesh grid. So instead of me saying n is equal to n infinity, all of this, right, I have to say n infinity. Now to make it n, x, and then y. So it means I have to replace all the t's with x and then the n infinities with y. So to avoid that issue, let me just put t here again and n infinity, so that MATLAB just overwrites it. Then I can type my n infinity here. So let's run this one last time, and we are going to get our graph, right? So what I was saying was that because we put x and y here, right, it means that I have to replace all the t's with x and all the n infinities with y. So that was what the problem was. If I don't want that, then I can just rewrite the t and n infinity, so that MATLAB is going to overwrite it. So wherever I see t and n infinity, it will replace it with the mesh form of the t and the n infinity. So another thing we could have also done was we could have typed, instead of typing self, we could have also typed mesh. So let me close this. We could have also typed mesh to get a graph. So we'll get the graph in this form, right? So we could have used self, we could have used mesh, any of them would have been fine. So that's how we go about a question like this. And we're also told to label the axis, so I can see that maybe my x label, so the x label is going to be the first thing we have here, which is our n. So I can say that maybe population, said n was the number of individuals. Let me say number of individuals. I can say my y label, and that one is going to be, the next one was n infinity. So n infinity is the maximum number, yes, the maximum population size possible. So max population size, and then we have our z label, and the z is going to be the last thing we have, that's t. So I can say time. Then for the title, I can say maybe population growth rate. So now if I should run this, I'm going to have all my axes labeled. I'm going to have my title come in there. So with labeling the axis, please take note. The first thing you have here is going to be your x label. This is going to be your y label. This is going to be your z label. So kindly keep that in mind. So this is how we go about questions like this. So just a recap. When you are working with these things, the sizes have to be compatible. So it's best to work with lane space and specify the number of terms you want, right? So from 0 to 100, I want 20 terms, or from 100 to 1000, I want 20 terms. When we are done, if you want a surface plot, we need to use the mesh grid function So I can replace t and n infinity with a mesh grid of t and n infinity. So it's going to combine them and get a matrix for me. When I'm done with that, I can write out my expression, and then I can use either mesh or self, right? So mesh, the function, and then the other parameters it was related to, that was n infinity and t. When I'm done with that, I can now label my axis. So the first one will be for the x-axis, second will be for the y, third will be for the z, and I can add my title as well. So thank you very much for your time.